Okay, now let's finish this chapter by estimating the sample size, the minimum sample size, in order to establish one particular confidence level for the interval. Now, sometimes we need to sample something and make a determination of particular characteristics about the sample, the population. Now, when we are dealing with just visual sampling, there is no problem at all. But there are some times that sampling is destructive. For example, if I'm testing light bulbs, I have to get that light bulbs and turn them on and check how many hours they last and wait until they broke. The same thing happened with bullets. Like you have to shoot bullets in order to find out if the bullets work. And in those cases, it's not that important, but there are some cases where the test is destructive, and also what you are destroying is very, very expensive. So you need to have the least amount of sample size in order to get a particular confidence level. And we might think about the cars, luxury car that has to be crashed in order to test, I don't know, the airbags. Of course, they do not crash cars or luxury cars. I mean, they should have another method to test these bags. But anyway, this is just to give you some real example of why you need to have this situation. Now, we have two situations where for the mean and for the proportion. Okay, let's start with the mean. The sample size for the mean. You know that the margin of error is equal to z sigma divided by square root of n. Okay? We have z because z of alpha divided by 2. We know what is the confidence level that we want to achieve, and we want to know the margin of error, but we don't have the n. So what we want to say is, well, what is this n in order to get that particular error? So this is the error. So my n, square root of n, is equal to z sigma divided by e. And I square everything, so n is equal to c squared, sigma squared divided by e squared, or is the error squared. When I have this situation, and what I need to do in order to find out the real sample size, I need to round up, always up. So if I have 87.1, it means that my sample size has to be 88. If I have 87.7, it is 88. If I have 87.001, it is 88. Okay, so always round up your number. That's it. This is the formula that you're going to use. So let's do problem 28. An online survey, a retirement plan provider and Harris Institute responded that 60% of female business owners are not confident that they are saving enough for retirement. Suppose we would like to do a follow-up study to determine how much female business owners are saving each year toward retirement and want to use 100 as a desired margin of error. So in this case, this is problem 28. The error is 100. So the margin of error that they want to assume is 100. 1100 as a planning value of standard deviation. Okay, so sigma is equal to 1100. And what is the sample size if they want to reach a 90% confidence? A 90%. So we're going to use this formula. So my n is equal to z. What is the c for the 90%? Go again to the table. What is the table? Table is on page 313. In a 90, my z is 1.645. 1.645 squared. Sigma, I have it, 1100 squared divided by the error, 100 squared, and that is equal to, I don't know, 1.645 squared times 1100 divided by is equal to 327.43. Since this is a number, we have to round up, and it's going to be 328. This is the sample size, the minimum sample size to achieve a 90% confidence level when my error, the error that I want to get, is 100, plus or minus 100. Okay, that's it. They want to know now the 95% confidence level. So instead of using 1.645, since the formula is the same, but instead of z of alpha divided by 2, z of 0.05, I'm going to c 0.025. That is 1.96 squared times 1100 squared divided by 100 squared, and that is equal to, okay, 464.83. We round up, and we ended up with 465. Okay, this is the minimum sample size in order to achieve a 95% confidence interval for my error of 100. So if you realize this, the higher the confidence level, the higher the sample size it has to be in order to achieve that particular situation. For a 99%, it's exactly the same thing, but I'm not going to do it. N is equal to 313. For the 99, my C is equal to 2.576 squared times 1100 squared divided by 100 squared. I don't know what is that, but it has to be higher than 465, because every time that you increase your confidence level, then your sample size has to be as well increased, because you want to be more sure. So that is the case. Now, the other thing that where we want to calculate the sample size is in the proportions. Okay, we have exactly the same thing. The margin of error for proportion is equal to z of alpha divided by 2 times p times 1 minus p. This is divided by n. Okay, since what we want to estimate is the p bar, so we cannot use p bar in the formula. What we use is a p star. It's an estimate, or if we don't have anything at all, we are going to use p star equal to 0.5. Anyways, so what is n? This is what I'm looking for. So the square root of n is equal to c square root of p times 1 minus p star divided by e, or the error. Okay? I square everything. It says n is equal to z squared times p star times 1 minus p star divided by e squared. This is the formula. Okay? That's it. This is the formula that we have to use. So let's do example 33. Okay? Again. When we have this, you have to round up in order to be more have more credibility. Always round up. If it's 35.1, it's 36. If it's 35.01, it's 36. If it's 35.9, it's 36. So round up, always. Okay, let's do problem number 33. It says in a survey, the planning value for the population proportion is P star 0.35. So in this case, they give us the P star. How large a sample should be taken to provide a 95% confidence interval? And the margin of error, 0.05. What we have to do is just plug these numbers in the formula, and that's it. What is my C for 95% confidence interval? We already know that. So 1.96 squares times P star 0.35 times 1 minus P is 0.65 divided by E squared 0.05 squared. And that is equal to 1.96, 0.35, 0.65, okay. Is equal to 49.58. Okay, so we round up and it's 350. So the minimum sample size in order to get a margin of error of plus or minus 0.05 when the P star is 0.35, it has to be 350. So the minimum sample size is 350. That ends chapter 8.